would equal 5. So what this means is that at some point we can have, if for example, if here is 1, then we look at, if we take 1 from 5, what is going to be left? Then you say what? 4. If we put 2, if f is 2, if we say 5 minus 2, we have what? 3. If we say f is 3, we say 5 minus 3, we say what? 2. So it means that where we have our question mark is going to be the answer we are looking for. So 5 is the constant that we have in this case because it doesn't change. And f is the variable. If we go back to the first example, we see that we have a constant, which is what? 3. 3 cannot change in this case, but m can change. Then we are looking for the answer, which is represented by the question mark. So what is going to be the expression here? The expression here is going to be what? 5 minus f. 5 minus f. So this is the word phrase, this is the model, and this is the what? Expression. Word phrase, model, and expression. Now, going forward, let's take another example. Another example we're going to look at will be, what if we have a word phrase, okay, let's have word phrase. Here is model, and we have the expression on this side. So what if we have this word phrase says 8. Okay, let's say maybe not 8, maybe let's say 4. For example, we have 1. We have 4 times a number. This time around, let's say n. 4 times a number n. How do we model this? The first thing we need to note is that n is a particular number, and any given number that is given as n, we have to have a duplicate of it 4 times. So if we look at it as continuous addition, then we have to add n to itself 4 times. So it means that n has to be exact itself. It cannot change. We cannot decide to pick random numbers. So what this means is that if you're modeling this, we're going to have a full stretch, but in this case, n will be exact. So this is going to be n, n, and n. We have n, so we have this. We have n, 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 and n. So this will form the full stretch of the number that we are looking for. Yes. So once we know the value of n, if you say, say for example, if we pick 1 as the value of n, then we're going to have 1 plus 1 plus 1 plus 1, and I'll have what? That's 4. It's the same thing as saying, okay, if n is 1, we can just say 4 times 1, and we have what? 4. Still the same thing. So this place is going to be the unknown. Oh, sorry, this is going to be the answer we are looking for. This n is our variable in this case. Okay, so this is the word phrase, and this is the model. And what's going to be the expression? The expression is going to be, we can write it as 4 times n. We can write it as 8 I'm going to write this is 4 times n. Sometimes we can do it like this, and we can say 4n. Yes, we can also do it as n plus n plus n plus n. Yes. This is it. So this is an example of what? Word phrase, model, and expression. Now, let's take the last example for this video. The last example is going to be on quotient, number 2. So what's the word phrase? This is going to say the quotient of a number n and what? And 5. The quotient of a number n and 5. So when we say quotient, it's part of our mathematical vocabularies that we must update ourselves with. We need to know what quotient is about. We talk about sum, difference, less than, greater than. We should understand all of this. Quotient is another word for division. Quotient is what? Division. So when you are doing quotient, there's a rule. If you say n and 5, quotient of n and 5, it's going to happen in one direction. The numerator is going to be n divided by 5. Okay, sorry, I'm already into the expression. So let's find the model first. So what this means is that the quotient of a number n and 5. So the full stretch is the n. And we are saying that we need to divide this n into what? 5 equal parts. 5 equal parts. So we need to have this, 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 and this. In that case, we now look at what is the value of each. What will it be? What would each part be? That's the answer we are looking for. But we already have these 5 together. Okay. So we need to understand the model. The model says the quotient of a number. That number is given as n. That's our variable. But we are dividing it into what? 5. So it's n divided by 5. The expression is going to be n divided by 5 or n over 5. N over 5. N divided by 5 or n over 5. So this is what we mean by quotient. So in this case, you are not allowed to say 5 divided by n. The quotient of a number n and 5 is not 5 divided by n. But if we say the quotient of 5 and a number, so we are always going to mention the first number that will come on the left side of the division sign, or which will serve as the numerator, because if we translate this into this form, we transform it, this is 5 over n. This is wrong for this expression, but if this is what we mean, we're going to say what? Quotient of 5 and a number n. I hope you have understood the concept of mathematical word phrase, modeling, and mathematical expressions. And I hope that you can on your own pick a few simple examples and try by yourself. Thank you. See you again in our next video.